All right, so this is our 3.1b, which is a review of the first 3 objectives of 3.1 in preparation for our test. We're starting with linear or nonlinear, and if you're on a device like an iPad or something where you have problems with clicking and dragging, you can tap and place. So you don't have to drag, you can just tap and place. Okay, if you find that easier. And this one's set up to be pretty easy. Yeah. This is mostly about being a review. If you talk yourself through it quietly, it should work out well. And then I will let you know, for instance, Walter and Jasmine have gotten them 100% correct so far. So has Rachel. If I haven't called your name yet, you might want to look back over and see if you have something to revise real quick. And then just as a reminder, both for those who are in the classroom and those who might be watching the video after the fact, from period 2 or period 7, I do have these set, so when I turn on the check option that allows you to check your progress, it only gives you points once you have at least more than half of the parts correct. It doesn't give you points for each individual part. And that is to prevent students from just grabbing any individual part, tapping it in there, hitting the check box, seeing whether that tells them they got a point or not, and then trying the next one and just guess and checking their way through. So you have to get at least half correct. At this point, Jasmine, Rachel, Sophia, Susanna, and Walter have everything correct. And I'm going to go ahead and turn on the self-check option. So if you haven't gotten them all correct, you can check that now. It does also tell me how many times you checked your answer. So I can also see that if it took you, 12 attempts. I'm going to see that. So don't check every single, don't like try every single individual one. Look over it and see. So at this point now you can check and see whether you got everything correct. You will see, is my demo mode on? Yes. You will see in the upper right hand corner something that'll tell you the number of points that you've earned so far after you do a check. Keeping in mind it gives you points for half, how many questions more than half correct. Okay. Let's see here. We're almost all there. A couple people. We are struggling a little bit with fraction words, so just to what's the word I'm looking for? To review. When we're dealing with linear functions, linear functions will have there'll be no fractional or negative exponents, no fractional or negative exponents. And then coming down here, oops, both x and y will be in the numerator. They will never be in the denominator. They will never be in the denominator. Okay, so we can change those. And they will not be inside of, oops, I have that in the wrong spot. They will not be inside of radicals. That should be everything everyone needs to revise to a fully correct answer. So linear functions will never, it's all about, to be clear, linear functions are all about the variable. They have nothing to do with the numbers, the coefficients, okay? And this is important because we want to keep track in our minds, guys, if I could have your eyes for a moment. We're going to talk about standard form. Standard form, the numbers matter. Whether or not we have fractions as a coefficient matters. But being linear or not, it does not matter whether we have fractions or decimals. What matters is just the variables, okay? So with that, we're going to move forward. Looking at number 2, is this linear or non-linear? And oops, wrong button. I am turning off where it's going to let you know your answer, because I don't want you to know right away. But I'm going to let you know how the class is done. Okay, is this linear or non-linear? Waiting for one more answer. Go ahead and give me your guess, linear or non-linear. One more answer. Everyone got this correct. This is non-linear. Good job. For number 3, explain your reasoning in fewer than 10 words. Explain your reasoning in fewer than 10 words. And there's a key concept I'm looking for here. And when you hit that key concept, I will score your answer. Ella and Rachel and Walter, I've marked that. Susanna and Sophia, I've marked that.
Basically.
Jasmine and Kylie, I've marked that. Ella, I've marked, oops, nope, said that already. Aiden, I've marked that. Okay. So there was one that I want to mention. Someone mentioned the variable terms in the correct order. So this is something I want to clarify. That has to do with standard form. And we're not talking about is it standard or not. We're talking about is it linear or not. So whether or not it's linear, the key concept is the power of the variable. Okay, so the people who got this, and you can revise your answer to match so I can score this. For something to be linear, the variables have to be to the first power. And this one had a variable to the third power. That made it not linear. Okay, so because it was not to the first power, it was not linear. There we go. Everyone's got that now. And we can move on to number 4. Is this linear or non-linear? Linear or non-linear? Okay, everyone has answered. Ooh, I have some people changing their answers. Okay. Anyone? Ooh, more people changing their answer. Anyone? I have 3 people who said linear. Anyone want to admit to saying linear in the minority? I'm going to raise their hand and say that was them. Walter? Anyone else? I was correct, and to be clear, that was Walter, Aiden, and Kylie said that this was linear, which is correct. Anyone want to, and maybe Walter, since he was just like, yep, I'll own it. Even though you're in the minority, and he was the first one who said linear. Do you feel like you could explain why you would say this was linear?
Well, I thought of things that wouldn't make it linear, like a fraction. It's not to the second power, and
yeah. Can you think of why you think other people would think this was not linear?
Because of the decimals.
Yes. Okay. So.
I was thinking standard.
Yes, exactly. So again, this is where I want us to really clarify our thinking. Linear versus nonlinear is all about the variable and its exponent. The variable and its exponent. Standard versus not standard is about the coefficient. But we're not asking is this in standard or not standard. All right, so it's okay that it has a decimal as the coefficient because linear or not linear doesn't have anything to do with the coefficient. Linear versus not linear is about the variable and its exponents. Does that make sense? Have we all changed our answers over to linear? Perfect. All right, so we can all get credit for that. So can we explain that reasoning now? That it's nothing to do with the coefficient. The coefficient being a decimal isn't the problem. Our variables are all okay. That's what matters. So think of how to put that in 10 words or fewer. And it's about our variable and the exponent of the variable. That's the part that matters. Okay. So to be very clear, specifically, I want something about about the variable. Okay, the variable and or the exponent. If you just say, oh, it's okay. So specific about the variable and or the exponent. There we go. All right. Everyone who has answered is now marked correct. So that's great. We'll move forward. Number 6. So we're refining our thinking. Number 6, linear or non-linear.
It's never on the two.
You have your notes, your 3.1 notes. We have some examples in our notes we could reference. Okay, everyone has answered number 6 correctly. This is non-linear. Let's explain our reasoning. What would be our reasoning for this to be non-linear? Make sure you use the word variable and don't just use the word fraction is not enough. We need to be more specific than fraction. Okay, so variable and something more specific than just fraction. Okay, let's go to Lena. You've got it. Okay, Susanna, you've got it. Hang on. It's here. Walter, perfect. Exactly the word I'm looking for. Sophia, perfect. Rachel, perfect. Ooh, Jasmine, can you explain why this was not the first power?
Well, I don't know if power was right, but it was a fraction, so it could always be divided more into something. So it wasn't just one number.
Okay, so remember I said we want more specific than just fraction, right? So here's the thing. What part, and let me ask this, what if we had 10, x over 10? Would that be nonlinear? Just having a fraction, would that make it nonlinear?
No.
So what specifically was the problem here, Rachel? Okay, so that the variable, we want to avoid pronouns in math because they're less specific. The problem is that the variable was in the denominator part of the fraction. Okay, 10 over x, that's a problem. x being in the denominator. And I like that you mentioned the power, Jasmine, because, and this is something we'll learn later, so we, at this point, we deal with them separately. We say we can't have x in the denominator, we need to have x to the first power. But later we'll learn that when x is in the denominator, this is the same as x raised to, and this is how we type a exponent, the negative 1 power, which is an exponent other than 1. When we have variables in a denominator, it actually means they have a negative exponent. So I thought it was kind of interesting that you were like, if it's in that bottom of the fraction, it maybe doesn't have a power of 1. So you were kind of sensing that something was off with the exponent being in the denominator, which I thought was kind of cool. Okay, so there we go. If the variable's in the denominator, then it is not going to be linear. So specifically being in the denominator, because it's not going to be to the first power. All right, that is everyone. Let's move on to number 8. Is this linear or non-linear? Linear or non-linear? And I do want to encourage us when we explain our reasoning to not use pronouns. You can say the equation, the function, the variable, the line, the curve, the function. I think I said that one twice. Okay, waiting for one more person. Perfect. Everyone correctly determined that this is not linear. The function here is not linear. Can you explain your reasoning? You could say the relation. So just most general, we could always call this a relation. The relation. Okay. Okay, let's see here. All right. So, number of things here that are getting full credit. If you mentioned it curved, that's good. If you mentioned it's not a straight line, that's good. I think that is everyone. So both of those are good. Most specifically, to be a linear function, it must be a straight line. So if it is not a straight line, it is not a linear function, or it is not a linear relationship. Number 10. Is this a linear or non-linear relationship? Linear or non-linear relationship. Everyone has correctly identified that this is a non-linear relationship. Ooh, so my question, and this confused my period 2 class, some of our students, because this is made up of some straight lines. So why would this still be non-linear, which you guys are correct, it is non-linear. Sophia.
Linear has to be a single straight line.
I love that word. Can we all explain our reasoning, including the word single, for number 11? Include the word single to explain our reasoning. Excellent. So everyone described in some way that it needs to be a single straight line, and this was not a single straight line. And we, for those who are in class, you'll see this in our notes. We included some examples. This, for instance, is not a linear function. This is, or linear relationship. This is the relationship y equals the absolute value of x. Anything hinky, we said, is not a linear relationship. This is made up of more than one straight line. All right. Ooh, how about this one? Number 12. A linear or nonlinear relationship.
Yay. Oh, come on.
Ooh, we have some division here. We don't all agree this
I'm
time.
gonna stick.
Ooh, it's almost, it's, if this were an even number of students, this would be split half and half. We've got 5 to 4 right now. Are we gonna switch over any?
No.
Yes, no? Okay. So, a slight majority accurately identified this. But if you have your notes, glance at them, see if you have an example in your notes, either on the linear or on the nonlinear side, that would cause you to revise your answer.
I feel like I got it wrong.
Because I specifically included one in your notes like this. Like you can change.
Wait, when you say looking at something, are you saying that for something in our notes that could change the answer?
That would give you information that might either confirm and you'd say, I was right. I see
Oh.
something in my notes that tells me I was right, and you'll leave your answer how it
It
is.
is linear.
Or you look at your notes and go, oh, nope, I was wrong, and you might change your answer. That means you would revise your answer. Okay, so because I haven't moved us forward, you can still change your answer.
Yeah.
If you had it wrong, you could change. Maybe you find it in your notes and you could show that to someone next to you. Oh, okay. We all found something. So we looked at our notes. We all accurately identified now that this represents a linear relationships, but I see some confusion in our faces. Okay. So we're going to talk about it a little bit before we just move forward. All right. Is this necessarily a line? We might not say, well, it's a line, right? I'm going to kind of face this way so the microphone can still pick me up. But would these points represent a line? Could I draw a straight line through them? Yes.
Yeah.
Okay. So this is why this would still represent a linear relationship. The points still would form a straight line. Okay. So with that, for number 13, go ahead and express that in your own words.
I don't know how to say.
I'm not looking for anything fancy, just the process of trying to figure out a way to say it, any way to say it, is still a learning experience. It deepens our thinking. Just make sure we have the word line in our explanation somewhere. So few people still need to add the word line to our explanation. Staples don't make good fidget toys.
Oh. Oh.
Okay, everyone has good points there. All right, we're going to pause here. This characteristics of standard form. Recap, we have our notes.
Oh.
I'm going to turn on the instant check so you can
Oh yeah.
check your progress.
Wait.
So number one, our equation should have no what? What's the first thing? Parentheses. Have no parentheses. I had a student yesterday say it should have no variables. It's going to be a little bit of a problem if there's no variables. So just be 3 equals 3. And that is not in standard form. And then our equation should be in the right. Okay, looks like everyone got that. First, our equation should have no parentheses. Then our equation should be in the right order. What should be first on the left?
AX term.
The AX term comes first, followed by
BY term.
the BY term. The only thing we should have on the right should be what, Susanna?
Constant.
The constant term. Okay, and so our final order should be, Rachel,
AX plus BY.
this is standard form. AX plus BY equals C. All right. Number 3, A, B, and C should have no, Elena,
Fractions of decimals.
fractions or decimals. So we should have no fractions or decimals all the way across. No fractions or decimals. They should also have no what, Susanna?
Common factors.
Factors other than 1. Or shared friends other than Fred. Okay. And then the lead term, which means the front term, which is usually AX, should always be what, Ella? Positive. I'm not sure why I went with 5 different options there. I think I put this thing together about 4 a.m. So there we go. Should always be positive. I was getting a little punchy here. Okay. Should always be positive. Good. Let's apply this information then. Number 15. Whoops. Clear demo responses. All right. Number 15. Is this in standard form? If not, why not? I'm going to let you know there's only one of these where it's both a problem with AX and BY. If moving AX would mean BY is in the right place, then we just say it's an AX problem. Okay. Is it in standard form?
Oh, okay. So we don't have to put the Y as well.
Yeah. Okay. And I am leaving these open for you to self-check yourself. So you can check your answer. And there's only one of these that you're going to check. And you can cross things out. This is a new feature that they offered, so you can strike out options on multiple choice. And it's only one, it's not a combination. So you're going to check just one,
I know. Wait,
not
so
multiple.
Not 2?
Nope, just one. There's only one problem with this, keeping it from being in standard form. What is the problem?
It's not leading.
There you go. Yeah, our AX term is not in the lead. If we fixed that, because that's our, if we go in order, first, is there a problem with parentheses? No. So if I, that's not a problem. Second is AX in the wrong place. Yes, if I fix that and move it to the front, in doing so, it would become positive and it would no longer have a problem with y being out of place. Okay, y isn't doing anything wrong. It's on the left where it's supposed to be. It's doing everything it can do to be in the right place, right? So it's not doing anything wrong. AX is the one that's doing something wrong. Number 16. Is it in standard form? If not, why not? So go in order. What is the first one? That is the problem that we would need to fix. Okay, looks like everyone's got this. Our front, oh, actually waiting on one person. We're almost there. So do we have parentheses?
No.
No. Is AX in the wrong order or place?
No.
Is BY in the wrong place?
No.
Is the constant in the wrong place? Are there fractions or decimals?
No.
Is there a factor common to all three, A, B, and C, other than 1?
No.
Is the lead term negative?
Yes.
Yes. Let me see how we can check them off as we go. All right. Moving on to number 17. Is this in standard form? Why or why not? So just kind of work through it just like we did the last one. Are there parentheses? Is AX in the wrong place? Is BY in the wrong place? Is the constant in the wrong place? Are there fractions decimals?
Yes.
Yes. Fractions decimals are a problem with standard form. They're not a problem with linear versus nonlinear, but they are a problem with standard form. Okay. Is there a common factor other than 1? No. Is the lead term negative?
No.
Okay, so this is our only problem. That means it's not in standard form though. And our problem is that there's fractions or decimals. Number 18. Is there a problem with parentheses? Work your way through.
There is no X.
Is X in the wrong place?
No.
No. So keep going. Is B in the wrong place?
No.
No. Okay, keep going.
Wait. I think I know.
Let's see if anyone gets there on their own. Period 2, we actually had a student come and do a great job explaining this to the rest of the class. It was so fun for me to sit back and watch the class disrespect him instead of me. All right, we have 2 people who've gotten the correct answer. Just keep working your way down, check each one. I've already crossed out 3 that are not correct, and it is not in standard form either.
But they do have a common factor.
Then check it. Okay, then keep going. Check the others. Oh, several people who are halfway there. Is C in the wrong place?
No.
No. Are there fractions or decimals? No. Is there a common factor other than 1? What is that common factor?
3.
Is the front term negative?
Oh, it's 2. That's why I'm not. I was like, why am I getting it wrong?
Okay, we got that?
Yes.
Okay, Number 19. Is it in standard form? If not, why not? We're almost there. Are there parentheses?
No.
Is X in the wrong place? Is Y in the wrong place? Is C in the wrong place? Are there fractions or decimals?
No.
Is there a common factor other than 1?
Yes.
What is it?
3.
6. We can actually pull an entire 6 out of there.
Oh yeah, yes.
Okay, is the lead term negative? All right, there we go. I think this is the last one of the set. Is this in standard form? Oh, actually, there's one more after this. Okay, so are there parentheses?
No.
Is AX in the wrong place?
No.
Is BY in the wrong place? Is C in the wrong place? Are there fractions, decimals? Is there a common factor other than 1? Is the lead term negative? So it's in standard form. So this is a mental algorithm that we want to be going through. We can use our notes to help us go through this mental algorithm, but that's the algorithm that we're going through. Okay, number 21.
Oh wait.
So for this one to mark correctly, and I wasn't sure how else to do this, X and Y, their places are swapped. To be clear, to fix this one, we wouldn't add or subtract anything because they're both on the right side of the equal sign. They just need to swap places. That would be the associative property that says we just move them around each other. So you'll get this one correct by checking both that AX and BY are in the wrong place. They just need to trade. So this would become 2x plus 3y equals -8. All right, number 22. What is our basic strategy for rewriting an equation in standard form? If an equation has parentheses, what do we do to deal with a problem with parentheses? Susanna?
Distributive.
We use the distributive property. So that's the first thing we do, and this order is intentional. If an equation is not in the right order, this is the next problem we deal with. Someone else, what do we do if the equation's not in the right order? Sophia, what do we do if an equation's not in the right order?
Like cancels without, so like add and subtract.
Yep, we add and subtract. Number 3, if the equation has fractions, Elena, what is our strategy?
Multiply every term by the least common denominator.
Multiply by the least common denominator. Number 4, if the equation has a common factor greater than 1, then we would do what, Ella?
Divide every term by the common factor.
We divide by the common factor. Generally speaking, we're going to either 3 or 4. So either we have fractions and we're multiplying by the least common denominator, or we have a common factor and we're dividing by the common factor. Okay. Fractions mean we're dividing by something and we need to cancel it by multiplying. Common factor means everything's being multiplied by something and we need to cancel it by dividing. The reason why then we do the changing the order before these, then we do this multiplication or division and check our lead term being negative, is because sometimes we can combine this multiplying by a -1 with steps 3 or 4, and multiply by a negative least common denominator, or divide by a negative common factor, and combine those two steps together. Okay? So what this means is, generally speaking, we're looking at a maximum of 4 steps, most times 3 steps, and we're going to just look at what would be our strategy for rewriting some of these in standard form. If you'd like to do this on a piece of paper, you can for the extra practice, but we're just going to look at what would be our steps, and this is very specific how you're going to fill this out, so I want to walk you through. This is in order on the left, and we're going to look at each of these and say, would this be my first step? If not, it will go down under the unneeded steps section. So for this problem, would I use distributive property?
No.
So I'm going to move this down under unneeded steps. Would I add, subtract to move terms? Yes, so that is my first step. Would I need to multiply by a common denominator? So that is an unneeded step. Would I divide by a common factor? So that is an unneeded step. Now we need to pause and think. After I add or subtract to move the term, will I have a negative lead term that I need to multiply by a -1?
In this case, yes.
In this case, yes. So my second step is to multiply every term by -1. Now, if we wanted to go ahead and do that, I'm going to do it on the board, so I'm going to pause my recording. Okay, number 4, would we use distributive, 24, would we use distributive property?
No.
No, so this is an unneeded step. Would we need to add or subtract to move any terms?
No.
So that is an unneeded step. Do we need to multiply by a least common denominator?
Yes.
Yes, to get rid of our fractions. So that is our first step. Do we need to divide by a common factor?
No.
Not if we use the least common denominator. So that is an unneeded step. Will we need to multiply by a -1?
No.
No, because our lead term is positive. It's x and it's already there. It's positive. So this is actually a one-step problem, which is just multiplying everything by the least common denominator. Number 25. Do we need to use distributive property to get rid of parentheses?
Yes.
So that is our first step, using distributive property. Will we need to move terms?
Yes.
Yes. Okay. Now we have to kind of think ahead. Well, no, not for this one. Will we have any fractions where we need to multiply by a least common denominator? No. So that's an unneeded step. Will we need to divide by a common factor? No, because y has a coefficient of 1, so there's no common factor. Now we have to think ahead. When I multiply this -8 times x and then move it to the other side, will I need to multiply by -1?
No.
No. So this is also an unneeded step. So this is just a 2-step problem. Yes.
Don't we do the second step multiple times because don't you have to add the 8 to both sides like that on the left side?
It will be multiple times because this is ax, by, and or c from both sides. So to move terms multiple.
Okay, making sure that it's not supposed to be multiple times. So it's just
So it's our second step. We will do it multiple times. So I'm going to demonstrate that in just a second on the whiteboard. Done. Number 26. Do we need to use distributive property?
No.
No. So that is an unneeded step. Do we need to move terms?
Yes.
Yes. So that should be our first step, even before we multiply times the common denominator. Okay. Then, do we have fractions to clear out with our common denominator? Yes, so that's our second step. Do we have a common factor to divide?
No.
No. Okay. And then will we need to multiply by a -1? No.
Oh no.
Nope, because our x term is in the front and it's positive. Okay, so this is a two-step problem. Number 27. Would we need to use distributive property?
No.
Unneeded step. Would we need to add or subtract to move terms? Yes.
Because they're constant.
The constant. We need to move the x. Do we have a least common denominator to cancel by multiplication? Do we have a common factor to divide out?
Yes.
Yes. Yeah, what is that common factor?
Oh.
2. Would we need to multiply times -1 to make our lead term positive? No. Okay, so this is a two-step problem. That's it. Number 28. Try this one on your own, and you can use the check button. There will be 2 steps. 2 things will go under number 3, and only 1 unneeded step.
Oh.
2 items for the 3rd step. And only 1 unneeded step. This is your challenge question. Ooh, Walter and Rachel get there first, followed by Jasmine and Ella. Great job. Couple more people getting close. Remember, only 1 unneeded step, but 2 third steps. You might find it helpful to actually write it down, work through it, because there are a lot of pieces here. And I'm going to do that on the board while you're working. Actually, I'm going to see if I can bring this up on OneNote and work it up on, for those who are doing this on paper. Okay, so this is y plus 2/3 equals 4 x plus 1. My first step is distributive property. Get y plus 2/3 equals 4x plus 4. And then I have a constant over here that doesn't belong. And I have a 4x over here that doesn't belong. So I need to add and subtract to get everything in the right order. I have -4x plus y equals 4 minus 2/3 is, as an improper fraction, thirds. 4 in thirds is 12 thirds, minus 2 is 10 thirds. Right? Yes, 10 thirds. Okay, now I have 2 problems remaining. I have a fraction, so I need to clear out that fraction and multiply everything by my denominator of 3. I also have a problem with a negative term at the front. So I'm going to multiply everything times -3. I can combine those 2 steps together and do them all at once instead of doing them separately, so that I get positive 12x minus 3y equals, my 3's cancel, -10, leaving me dividing by a common factor as my unneeded step. There we go. All right, and that is our review of 3.1 objectives 1 through 3, rewriting equations in standard form.